Welcome to the video on function composition. Function composition is when you compose, that's the verb we're going to use, when you compose two or more functions. So in other words, it's when the input for a function is another function. So when we write this down, instead of writing something that says f of x, we could write something like f of g of x, right? So see how the input area has a whole nother function in it. So the other notation that you may see, I want to say that the SAT likes the other notation better. It's going to look like this. F of g of x. So it almost looks like it's spelling the word fog. This is just like an open circle. I may have drawn it a little too big. It looks pretty small when you see the notation on a standardized test. But just so you recognize that this symbol really is the composition symbol. So we're going to start off with some examples. So I've given us 3 functions to work with, and we're going to compose 2 of them for example 1. So this is saying that f of x is the input for g of x. So f of x is this stuff up here, right? The x minus 2. So this is really saying to input x minus 2 wherever we see x in the g of x function. So the g of x function is just this x squared. So we're going to substitute in an x minus 2. Notice I put that in parentheses so it all gets squared to get our new composed function. And if we wanted to actually square this, we could. I don't see a need in doing that right now. I would just leave this as the answer. The other example is just showing you that composing the same 2 functions but in a different order actually gets you a different answer. So this operation is not commutative, right? So the order matters. So let's try this. Now, g of x is the input. So we're going to do f of x squared. And x minus 2 is the f of x function. So we're going to replace that x with an x squared. And then subtract 2 from it. So notice these 2 answers are different. Right? I mean, they're kind of similar in that they're both quadratic, but they are definitely not the same function. Let's do some more examples. So we're going to stick with those same 3 functions, f of x, g of x, and h of x, but this time we're going to work with h of x, and our input right here is h of 1. And notice we even have another number here that we're going to need to input first. I'm starting with the inside here. That's our input. So what is h of 1? Okay, if we come over to the h of x function, I'm supposed to plug in 1 for x. So that would be the square root of 1 plus 3. That's the square root of 4, and the square root of 4 is 2. And we're just getting positive 2 here. The square root symbol was already there. It's only the positive version of the answer. So h of 1 leads us to 2. So these things are equivalent, h of 1 and 2. So I come back up here, I'm going to replace this h of 1 with a 2. So really this question is, what is g of 2? G of 2, okay, I'm just going to go back to my g of x function and plug in a 2 here. So we would do 2 squared, which is 4. So there's just another way of showing you that you can compose functions, right, when the input isn't a variable. Right? I'm still going to get a number. I'm evaluating that function. But actually, there's something else we have to worry about. And I believe it's going to happen in this very next example. So beware, something special is happening on this example. We're going back to just inputting the function h of x, right? So this is our input. So I'm just going to replace that h of x with the square root of x plus 3. So that's going to get inputted into this function up here. So the square root of x plus 3 is being squared. So squaring undoes square rooting. Those are inverse operations. So we wind up with just the x plus 3. So now here we have an issue. And you wouldn't really notice that there is an issue until you do something with it, but I'm going to point it out right now. We started inputting a square root function into a quadratic function, and we wound up with a linear function. So these issues are going to occur. Notice I haven't even said what the issue is yet. I'm just kind of preparing you for it. But these issues occur when you start changing families of functions. And when I say families of functions, I mean the square root, that's a family of functions. The quadratic is a different family of functions. And linear, or lines, those are different families of functions. So we're dealing with 3 different families here. And whenever those families start to connect with each other, kind of overlap and be used in the same problem, issues arise. So here is our issue. When you start with a square root function, that is your input, right? This h of x, this was your input. And the input had a domain of what? Let's see. The domain here would be -3 to infinity, and we can include the -3. -3 is fine. That would get us a 0, right, as an output. So we had this restricted domain. So if our original input already had a restricted domain, then my final function over here must also have a restriction. So think of it like this. Here's a number line. Let's call this the x number line. And we knew that this number line was already cut down, meaning it had a restricted domain, to this section right here. So in other words, if there was a number over here, let's say -10, and you plugged it in to h of x, it would be undefined, right? So all these numbers are out. So what happens now is that I look at this final function and it's a line, and you'd think to yourself, well, the domain of a line is -infinity to infinity. That doesn't have any problems. But we already started with this restriction. If we couldn't have plugged it in here, right, into the input, there's no way I'm going to be allowed to plug it into this one either. The question really remains is, did this add any other restrictions? And since it's a line, it didn't add any others. We're just going to keep the domain of the original restriction right here. And what's hard about this type of question is that nobody asked for the domain of that. It automatically has to be part of the answer. If you looked at this x plus 3 and you were to graph that, you would have graphed a line. And because you have a restricted domain, that would be incorrect. Think about it. Even look at this right here. It's a ray, right? That's not a line. It has an endpoint on one end and an arrow on the other. This is mandatory. This isn't something that I had to ask you to write down. It is legitimately part of this answer. So whenever you're doing compositions, it actually happens with inverses as well, which we will get to in this unit. You have to be very careful when you start crossing those boundaries of families. So this is the entire answer for this problem. And we're going to see more as we go along. So here's another example where we have a square root function as our input. So let's start there. We are now going to do m of the square root of x plus 5. And we're going to substitute this one now as an input into a rational function. So that's a function where you have variables in a denominator. And in this case, that square root of x plus 5 is going to be squared. So just like the problem we just did, it seems like we're going from families that are square roots into families that are rational. Here they're still rational, but it looked like we were going to have a quadratic down here. It turns out that denominator is just linear. Okay, so you'd think, okay, we'd circle this answer and move on, but that's not the case. We have the issue happening on this example as well. So, top right up here is our input. Domain starts out with a restriction of -5 to infinity. I'm going to make that number line again. So think of this as our domain, right? So right now, our domain has been restricted to -5 and greater. All of these inputs are perfectly legit. The question is, does the new function have any more restrictions on it? And it is a fraction, right? So we do want to be aware that we don't want this denominator to equal 0. So what value would we plug in for x to make the denominator equal to 0? -5. So let's come back up here. Let's see if I can erase this. Yep, there it is. We don't want to include -5 there. Oops. I really do like thinking of the number line. It helps me a lot. I hope it helps you. It just made this restriction get cut down by one value. I can't include the -5 now. -5 would cause a problem. And although the numbers that are below -5 wouldn't cause a problem in this function, it was never allowed in the original restriction, right? So this red representation of our domain is what has to be included. So regardless of anybody asking me for what the domain is, I still have to include that the domain is not including -5 and then to infinity. So that would be my final result. But for one final example, let's try this one. We're going to have p of x as our input to w of x. So let's do w of x squared. So that would be 1 over x squared plus 1. And we're doing this changing from families of functions again, so let's just double check. The original input had a domain of, let's see, this one, oh, this is nice. This one didn't have any restrictions, so -infinity to infinity. This could cause some problems as it's a fraction. Let's see, what could make the bottom equal to 0? Well, something squared is always positive, and we're always going to add 1 to it. So there's no way that this bottom is going to be 0. So I actually think that we're okay on this one. This one we didn't need to do any special domain restrictions on our answer. And we are done. So in class we will do some more examples, and good luck on your survey.